Yeah, we're live. Come on. See if my, come on. Look at that magic. I need to have that in front of me all the time. Nobody wants to look at me anyways. But we are live and it is 12:23. I just put up the video on the airfield distribution running the M90, the junkyard M90 supercharger on top of the high ram. We have that rectangular discharge area basically on the adapter plate because that's where it comes out of the supercharger. And that's pretty normal for a lot of these root cell blowers. I mean, the old ones like a 671, 871, those feed in from the top and exit out the bottom. But most of these modern EFI designed ones have, a front or back feed, and then the exit is on the opposite end down below. So the question became when I was doing this, especially when you take and put the plate, mount it on the high ram, and you look down in the discharge in that rectangular hole in the plate, in the adapter plate, you look down and you're like, that's right over those four cylinders. There is no way that airflow coming out of the blower cannot just overfeed those four cylinders, because the plate is not too far off, whatever the distance is of, from the flange on the high ram down to the runners. Because even when they put the other, lids on the high ram, it always has, it always has a rounded top or a squared top with added plenum volume on. So if you just put a flat plate on there, you would think it would be less than ideal. And then putting, obviously, because it was never designed for somebody to make an adapter plate like I did and put a M90 junkyard supercharger on there, and it's positioned right on top of those. And then the other four are, they have to exit stage left or back. And so the airflow has to come down, not all go into those four cylinders, and then go to the back four also, because everybody's got to be fed evenly. And yet, when you look at, if you go take a look at the video, you'll see that it actually did not turn out the way that I thought it was. I thought that we would see a distinct change in the air fuel favoring those front cylinders. I thought that we would see that, essentially, because we're supplying the same amount of fuel to all of them. I'm not running closed loop, I'm running open loop. So the amount of fuel that is supplied once I adjust it is the amount of fuel supplied. And so we have a fixed amount of fuel going to them. And then, so the only thing that's going to affect the air fuel would be, airflow distribution, hopefully caused by the position of the supercharger. So if we're favoring airflow on the front four, they would be leaner. They have the same amount of fuel. If they have more air, that's a change in air fuel ratio. Pretty easy to diagnose. The other way we could do this, and I thought about doing this too, is making more runs. Sometimes you just run out of time for all this. But I could hook the map sensor up to each individual cylinder and kind of data log that on the HOLLEY and see where we are in terms of, first you'd have to make several runs in a row and make sure that you didn't have an air fuel change, because this is all part of testing. You have to do this. And we saw these kinds of things with the O2 sensors, and we'll get into that in a second. I'm losing my light. So if you were going to test, if I was going to put a map sensor, just the same one, because you want to use the same one. You don't want to change in map sensor, because then you're throwing another variable in there. But if you have the same map sensor and you make successive runs, just moving it over to each of the cylinders, and then you could get an idea of, hey, where am I getting more boost? That should also give you an idea if I'm getting more boost in one or more of the cylinders, then that should equate to a change in air fuel and a change in power in those cylinders. We did it with having 8 O2 sensors, one in each one of the cylinders, in the headers. So we have headers, the 802s, and we ran them on there, and I could show you what the air fuel is in each cylinder. The thought being that if we have more airflow in one and we have the same amount of fuel, we're going to change the air fuel. We'll be able to register that in the header, and away we go. And that's exactly what we did. But we didn't see what we thought we were going to see. And I kick myself for not running the HOLLEY high ram with 802s NA so that we could see what the air fuel distribution was NA. Like, what does the manifold do all by itself? When we don't have a blower blowing air theoretically into the front four cylinders, what does the thing do anyway? And then we can kind of have a baseline there. We could go, hey, look, this is what it does. And then we can look at it and go, look, on this motor, even NA, we're getting this kind of variation in airfield. Maybe we don't get any. Maybe it's perfect. Maybe it's, maybe that high ram design, because all the runners are the same design and the same length and the same shape and stuff, that maybe that would be, maybe we would have even airfield distribution in all the cylinders. Again, on this 4.8 liter, that would also assume that all the cylinders are sealed up evenly, which I kind of doubt is the case. So the motor has to be cooperating as well as the intake manifold, as well as the airflow into the intake manifold. Because if we have a front entry throttle body, does that change distribution in the manifold as opposed to having, I think that the ideal situation, if you're going to do it NA, and we've always made more power this way, when we run a high ram, we run two 4150s, or ideally two carburetors on top of there. So we get charge cooling as well. So we get even distribution in each of the cylinders that way. So if you had airflow going that way, then I think you would not be introducing a variable of how the air is coming in and then changing the airfield distribution that way. But I did not do that. So all I have is the data that we got running the supercharger on there. And quite honestly, it surprised me. When I saw the air fuel on cylinder number 1, I thought, okay, that's kind of how they're going to be. We're going to see leanness on the front four. But that didn't happen. We saw variations in cylinder to cylinder that were much greater than front to back. Even just between the front four, we saw a big variation. Some of them were lean, some of them were rich. It was a big variation. And the same thing in the back cylinders. We just didn't see any direct correlation between the position of that discharge, which is good, because that tells us that, hey, look, what that tells us is there's enough plenum volume there. There's enough area for the pressure to be equalized all the way through. Now we could do, we could tap again with our map sensor. We could tap different positions on the plenum and find out, hey, look, we could kind of do we could pressure map that and go, hey, look, the pressure is this much here and this much here and this much here, and then maybe do all four corners or do the middle, wherever we wanted to take it from. And we can kind of get an idea that, hey, yes, indeed, even though it's coming out right there, we're still getting fairly good, distribution of boost. Hopefully that equates to airflow too, in evenly in the common plenum of the high rim. And so I honestly, I think that that's what's happening. I think we have enough common plenum there that there was enough for it to make the turn. And that tells me that me putting a little ski jump on it and trying to direct some of it toward the back probably would be a waste of time. And I also didn't do, when I was doing this testing, I didn't do individual cylinder trims to try to bring them back in line. I've done that test before, and there wasn't a big change in power from doing that, but there would be a big change in safety, particularly cylinder number 1. It was all the way up to 13-1, which is too lean for what we were doing. So then you'd have to add fuel to that and then lean out the others. And, unless you did it with an individual cylinder one. But now when I do that, I'm going to add some airfield to cylinder number 1, or add some fuel to cylinder number 1 when I'm running this. Even if I don't do 802s, I'm going to do that now. And I'll use that data as information when I do more testing with the supercharger, which I'm definitely going to do. And I think I'm going to try to run it on the 5.3 next. I'll put a smaller camshaft in it, so we're not making as much NA power as we've already made with the blower. So we could bring that down a little bit. But I think on the 5.3, I think we're going to see some pretty big numbers with this thing. I'm just hoping that the snout of the crank doesn't break, because it's not in good shape on the 5.3. Every one of these junkyard motors has some kind of problem, and that one definitely does. So we got good airfield data on that, and that was cool. Now I'm waiting to get the TIC Performance air to water intercooler, which is also beneficial and I think will be helpful, because this helps in two ways. One, ideally, when you're introducing the airflow like we're doing into this common plenum, you want to have enough room so that you can get equal distribution of the airflow and the boost in all the cylinders. And I think we have that. If we run the air now through the TIC Performance cooler, and we don't have plenum between the blower and the cooler, we're only going to be using a portion of the cooler. Now, in this case, it's probably way more cooler than we need. I mean, if we're using half of it, this is easily 1,000 horsepower cooler. So 500, we would be enough there. But I think what they're going to do is send standoffs or spacers so we can move the plate up away from the move the plate up away from the intercooler, and then that way we can have some common plenum between the manifold or between the intercooler and the discharge of the blower for the same thing, so that we can use more of the cooler and get more cooling. We could get all that air to pass through the whole surface area of the intercooler, and then we know that even distribution is going to happen on the other side, even if it doesn't happen on this top side. But I just want all of the hot air to go through the cooler and maximize the use of the cooler, so we have cold air to all the cylinders. So we don't have, we don't so the back ones aren't getting hotter air and the front ones are getting colder air, or vice versa. We just don't want that to happen. So I think that problem will be solved and will kind of take care of itself. But that will be more interesting testing. So I'm looking forward to doing that. And of course, as always, and everybody says, well, are you going to do 2 of them? Yes, I'm going to do 2 of them. So we'll do that. And that will be fun because, 2 is obviously better than 1. And then we can try to make 1,000 horsepower with one of these with a twin blower. It will not be twinner cooled, but it will just be a single intercooler for both of them. It will still be this TIC performance one. So that should be fun. We'll see what so you guys have going on. Has anybody watched the video yet? So we got to start a poll. I run the Okay, so the poll is, if I run the M90 on a 5.3, that L33 that's already making more than 500 horsepower, will the supercharger bring that up to 600 horsepower because I'm going to also run the TIC air to water intercooler. So if we run the intercooled M90 on the 5.3, will it make 600 horsepower? Let's see what people think. I run the M90 on the 500 plus horsepower 5.3. Will it make 600 horsepower with a TIC air to water intercooler? We got 100% saying yes. Oh, it's back down to 60%. Trying to get big fluctuations from people. So let's see how everybody's doing. Burnsy, John, what's going on? Eric, Joshua, Dust Demon. Getaways here. I want to see the M90 on an LV3 4.3 liter. It should do well on that. We know that it's a 500 plus horsepower blower now. And so on an LV3, if that's a 350 horsepower motor or 400 horsepower motor, then it should do well. Has anyone ever tried a Motown 2 Gen 1 block that uses an LS top end? I never have. I've only seen them at the SEMA show. John, you got your title for the Explorer this morning. Fighting for 4 months. Oh, that's not good. I got the micro squirt in today. Time to start installing. Turbo Sensor, good luck. Please let us know how that's going. So Burns, you did spend some money on the Cyber Monday, Black Friday. How much work is it to install a map sensor in each runner and a thermocouple in each exhaust header tube? The headers that we have already have EGTs, but quite honestly, I don't care about EGTs because they don't really give you too much information, because the timing greatly affects exhaust temperature. So the air fuel gives us much better information, but a lot of the headers that we have already have that. But a map sensor is just a matter of drilling and tapping a hole and putting a fitting on it, like a barb fitting on it, and then just running it out to a map sensor. Turbo. So you got 30-inch leads. So you're gonna have to put the plugs on all of them, but that's okay. You can put the ones on that you need. Are you using GM sensors for that? No point add a map sensor at each runner. The reason I wanted to do that is I wanted to check, boost differential in the runners if there was any. When you get to an individual wideband setup, that had to put a dent in the piggy bank. yeah. Luckily, that's Westech's deal, so that's not. It was not my. I wasn't paying for that. K-types are slower, but they still tell you if your airfill is lean. So you're basing rich and lean on your exhaust temperature? I wouldn't do it that way. Yeah, Burns, that's a good idea. Get a like a bulkhead plug or something so that you can have unplug it all on one side. OEM, LQ4, LQ9 cam, and a 5.3 for the M90 test. Do I want to do that? No, I don't really want to do that. I'd like to see a drift cam test. I honestly don't know that a drift cam, in terms of power, the way that we would run it is going to show much more than whatever the duration and lift specs are. Just watch it prior to joining the live chat. Let's see. I'm gonna get down to you. $10 man. Who is that? E1337. Just a little gas money for the road trips. Thank you very much. I'm gonna get down to you. I'm still scrolling down. What's your opinion on flat tappet cams? I've run lots of them. Looking at a Nova with a hydraulic flat tappet, an Audi cam, and a 383. Should I avoid it and just get something a roller? Does the motor already have a flat tappet in it? Is it already running? I wouldn't worry about it if it's already running. Burns, you did watch the video. Good. What difference is there between having one large blower versus two smaller blowers? Usually that's a packaging thing. A packaging or a sizing thing. If you have, you'd pick the blower or blowers to supply the amount of airflow to make the power that you want to make. So having one of them or two of them is going to usually be more of a fitment thing, just like with turbos. Just clicked on the video and saw you were live, so I jumped on. Notifications are always 45 minutes late. If you've seen the notification already, are you talking about the notification for the other video? Because this one just happened. I have to vote no on this one. You don't, James, you don't think it will make 600? Anybody try mounting an M90 to a Volkswagen engine? That should be doable. It's just a matter of making a bracket, and then you're just blowing the boost into it. Definitely just a two-step. Spent way too much money, but you'll have a great Christmas. Did you buy yourself Christmas presents? Because that's always good. Just a little gas money. Thank you very much. That might be. It doesn't. Where we go to happy hour is not really very far, so that might be drink money, but that's all good too. The only time I've used EGTs are on bikes, and there isn't room for O2 sensors. Yep, GM sensors and Honda throttle body. Okay. Spent some money over this weekend. Can't seem to figure out the Quadrajet on my 72 SS. I bought a HOLLEY spreadboard to rule that out. Initially, fuel pump change, got it running. Anyone make an adapter for an M112 for the LS? I have a Magna Powers blower off my Lightning. Yes, they do. Tom Demuse from Demuse Engineering makes one. I don't know if, I think it's for a 112. I know it's for a 122 for those. We just make sure on the EGTs to get the cylinder, make sure that they're even. That's a good idea. And the reed plugs. Yeah, blue collar. Let me know if the carburetor does. Although we don't let them sit too long without running them again, but we have carburetors that we've had for a long time at West, but they don't sit usually for a long time. Some of the less popular ones do, but yeah, Burns working on the Volkswagen stuff, the 1.8 Ts. Yes, specialty tools for everything. It's expensive just to buy the tools just to fix everything. But a 1.8 20 valve deal would be cool in an early Rabbit. That would be awesome. Get some drinks at Pietro's. Yep. Are you local? Do you know Pietro's? What do you think about the new 2024 F-150 sleeper package? I haven't seen it. I don't really keep up too much on new introductions for vehicles, but I could take a look at it. Your car sat for almost a decade. Yeah, 10 years could cause problems. Maybe you should use the same sensors all the way around. If the sensors vary slightly, how can you get accurate reads? That's Keith. That's what I was talking about doing. I was just going to make different runs and move my map sensor, just basically plug it into a different vacuum line all the way around. And then that way we know that the sensor is the same. The map sensors, you can get map sensors that are very, very similar. They're made by the same manufacturer. And what I would have to do to make sure that that's the case is we would verify it. We would make runs with one map sensor and then plug the other one in and make runs with it in the same port, in the same position, and just make sure that it's exactly the same. Is the KPA reading the same? You'd have to make runs with one sensor several times, make sure that there's no variation run to run from just the same sensor. Then you have to go in and change sensors and then make a few runs with those and make sure there's no variations. And then it's a whole procedure. It's a lot to do that. And that's why that sort of testing is expensive and time consuming. And then, like I talked about in the video, the sensor that we run, that we have connected feeding air fuel data to the dyno, is different than the sensors that we ran when we're running 802s. And so there's a variation or a difference in the air fuel readings that the 802s have versus that singular one as a combined amount that doesn't equal what it should be with those four, according to the data from those four. So it's a lot. It's a lot more to take in than people think. What people think is that, oh, those are exactly the same every time. So you just add those up and that equals that. And that's how life is. But it's not like that. M90s are in almost everything from the 90s. What makes it so viable to use compared to other superchargers that you could get it as cheaply and accessibly. The M90s are the ones from the V6s specifically they made millions of them. So they're readily available and they're inexpensive. So they're accessible. And then we just want to show what kinds of things that you can do with those, even though they're limited in how much power and airflow they'll supply. You live in where's Madison at? My brother has a Mark 1 cab and I had a Mark 1 Fox, 2-door, trunk, 5-speed. Never should have sold it. New truck for me is 10 to 15 years old. I have an 02 Silverado, so that's my new truck. Absolutely horrible to work on. 6 likes. Come on, guys. Yeah, well, we have more now. We have 24, but we're still only at 50%. Rich, calibrate a bunch of map sensors. Could you not do a static test by using an air pressure vacuum pump to calibrate all the sensors at once? I guess if you could make sure that they're the same, as long as you can get pressure evenly to all the branches of your octopus. It feels like accelerator pump issue, but the rubber is fine. There's a small check valve in the accelerator circuit that I've had getting stuck after sitting. What is your opinion on the best LQ4 setup for durability? Well, what is it you're trying to do? The best one for durability is the stock one. So if you want a motor that's going to last a long time, run a stock LQ4 and change the oil in it, and then it will last forever. Mine's a 5.3 and LM7, but it has 330,000 miles on it now. So it's really hard to beat factory stuff. But I'm assuming that maybe you want more power too. So tell me what you need. Going in an 85 C10. So do you want something more than stock in terms of power? Because a stock LQ4 in a C10, if you're just driving it around, a stock one works really good. That's a one with headers and a good tune on it is 400 flywheel horsepower. It's on the 505 and Highway 16. Okay. Let me see where that is. Madison, California. Oh, so it's 25. It's only 20 miles away. Okay, up to the left of Woodland and stuff. Okay, I got you. Up past Winters. I've been through there. Esparta, so we played them in various sporting events and stuff. Blue collar, what's your experience with vacuum boost manifolds with sensors plugged directly into them? I have a good vibrant one. I want to clean things up and just plug them all in. Burns, that's actually what I need. Somebody told me, probably you guys told me that Vibrant makes one. I need one of those for the dyno rather than having to hook up 25 vacuum tees and stuff. We just need to have that on the dyno. It needs to be there all the time. So that we just run the big line to it, and then we can run all the kinds. So because we always run, especially if I'm running twin turbo stuff and twin wastegates and a blow off valve, and so you have and a reference to the regulator and all that stuff. So you have like an umpteen million different vacuum lines that you have to run to stuff, and having a manifold with a bunch of fittings on it would make life a lot easier. Bear. How's our poll doing? 66-34. So only 2/3 of you thinking that it will make 600 horsepower. So what if I put it on a 700 horsepower 6-liter? Then will it make that? Michael, I don't have any merchandise right now. And I've said that for more than 2 years now. V8 Velocity, what's going on? My light came back. I'm going to tell you I have to get another one of those. Was this run on E85 or pump gas? The blower test was run on E85 only because we were looking for more power. Quite honestly, it was only at 8 pounds of boost, so we could run it on pump gas. It just doesn't make as much power. I got push lock vacuum lines for it as well, so I don't have to worry breaking or drying rubber hoses like silicone. They can collapse if you get the wrong ones. Yeah, I've seen that. We've melted some hoses on the Bonneville car going to the wastegate because that gets, as you might imagine, gets pretty hot. So we got to use good line. I think it'll be tight making 600, but I'm hoping that it does. Me too. I think that would be cool. I mean, if we can get the boost down to 0 with the blower, and we can also spin the blower a little faster. I need to send a note to the guys at ATI about that. Packaging wasn't an issue, which is preferred to use. There's no preference. All you're looking to do is size the supercharger so it will do the thing that you want. That one of them isn't better than the other. What I want to know is when do we start making cap screws and bolts that directly take a 1/4 3/8 or 1/2 inch drive? Oh, so you want a square head on them that take those? I finished the head work over the weekend. Hopefully it flows better. So you did a little porting on it. That's good. 25 degrees is far too cold to be doing front and rear drive lines on the ground. Yeah, you don't want to be laying in that. It's a nice part with the Teflon push lock stuff. You can get as stainless steel fittings for wastegates and turbos, and that will stand set 700 degrees of direct heat or something like that. Yeah, that would be more than enough. We just had rubber hose on it with a zip tie. That probably wasn't cool. Spraying water or water meth before the blower would help the blower. How is that going to help the blower? It's actually going to displace some of the airflow of from the blower, and I think that might hurt power. Little liquid intercooler, yeah, nitrous would definitely help it. We're already going to run an intercooler on it. We have the Tick Performance intercooler for the high ram, which is ridiculous for what we're doing for a 500 or 600 horsepower motor. Oh, so you think it's going to seal the rotors? That might be something there. Vice grips, yeah. Does plenum volume affect a blower motor at all? Will more or less volume add or take away power? I honestly don't think so. The rotor sealing, we know that rotor sealing will add power because we know that if the rotor is tighter or if you have Teflon strips on it, that it will definitely improve. And that's why they coat the rotor so they can get better sealing. So it might be that a good blower, this one is, I'm sure, used and tired and stuff. I haven't looked inside to see what the rotors look like, but I'm sure that a new blower that has the right, and since we're only running a limited amount of boost, we're not getting a lot of heat in the blower. So we could have fairly tight rotors, I think, on this combination. Plenty of volume is an empty rabbit hole. I agree. Somebody just was arguing with me about bore versus stroke again today, and and the interesting thing, and he might be here, it might be one of the viewers. If you are, please chime in. But what the interesting thing was, and we've talked about this before, but he's saying, but I've gone through all of your data and I've looked at all of your graphs, and he's trying to argue with it that the bore or that the stroke makes more of a difference in the power curve than bore does. I'm like, look, it's displacement. But I said, look, your first red flag should be that you're using my information and my data to try to argue with me. I said that should throw a red flag for you. I said, but you'll learn when you've done this for 30 or 40 years that when you have all this data, that the displacement is the big thing. You go from a 4.8 to a 5.3 to a 6.0 or 6.2 or 7 liter or whatever it is. That's the big thing. Then how you get there, then we can talk about that as a little thing, but it's not all one thing. It's both of those things. And you know, what can you do? You can usually see chipping on the rotor coating if it's bad. The Gen 5s are better than the Gen 3s. Yeah, and this is a Gen 5, and it does have coated rotors. So maybe I'll just spray the barbecue spray paint on it, and that should be fine, right? Bore versus stroke. I thought the real limiting factor was the piston speed in the bore. No, if you piston speed isn't an issue in any of the motors that we're talking about. If you look at the piston speed on some of these mountain motors, it's ridiculous. Yeah, according to your data, you're wrong. I know, Bear Burns. I don't know. Yeah, what can you do? Blue collar. I'm thinking that the Gen 5 stuff is, somebody may correct me here, 2003 or 2004 and up on the 3800 V6 stuff. Looking to do a big turbo on an LS, trying to make 1,000 wheel horsepower, kind of a budget build, but obviously still expensive being fully custom, going to a CL. What is a CLS? Summit LM7 build or build a junkyard. Okay, so 1,000 wheel horsepower is actually very, very easy to do. So if you take it, well, hello, come up here, come here, see, come on, come on, look. And no, I know. Did you come up to visit? I'll come down and give you food in a second. Okay, come on, let's go. Oh, okay, come on, let's go. Come on, turn around. There you go. Go get your brother. Go get your brother. That's Bruno. That's Bruno. On the LQ4, LQ9, a 6-liter with a cam and springs and the right amount of fuel and a 1,000 plus horsepower turbo, it'll be easy for you to make that power. Mercedes CLS had a 5.4 aluminum stock block. Okay. Gen 5 is 04 to 08 on the Grand Prix. Okay. Other W buddies like Monte Carlos didn't get the Series 3 3800s. Okay. Yeah, JK, that's a good point. On the affiliated, like I said, making the power, making 1,000 horsepower, very simple. Whether it's a 4.8 or 5.3 or 6.0 makes it even easier. And you can do it with any of those junkyard motors because that's not hard to do. That's just boost on top of an NA motor that makes between 450 and 550 horsepower. And then it's just the boost number on top of that to make the power. But all the other things are going to be really expensive, like people have pointed out, transmissions and rear ends and drive shafts and things like that. Bruno and Milo and Brady too is the other one. He's not up here right now, but he was downstairs looking at me, wanting me to come back down. They're probably, it's 1 o'clock. Yeah, they're probably hungry. You scientists, a lab inside your home. That's right. 3 golden retrievers. Three Goldens. They're awesome. Although one of them, we took them up to Apple Hill with family up there, and we were walking around, and they're just so happy to see everybody. And they, I had them on the leash and stuff, and they went over by another dog, and the dog was really not a good dog. He ended up biting Brady. People are sketchy dogs. Sketchy. Putting some Bill Stein shocks on my dad's truck. Told him it sounds like a knockoff, but he got them anyway. Some Bill Stein or some Gloria Stein. My dog's always like seeing yours. I know and more so Bruno than Brady, but they both will, whenever they hear a dog on the TV, they jump up on the TV, jump up where the TV is and try to get the dog on the TV. And same thing on my phone. If I watch a dog video, which I watch a lot, and they can hear the dog barking or anything, they're like immediately on alert. What size injectors would be best for a GT45? Looking to make 800 horsepower would be really hard with the GT45 on a 6-liter. 700 horsepower would definitely be doable. But 80-pound injectors, if you're doing it on gas, is fine. That Bill Stein knows the shocks. All the whole Stein family. Bill Stein, of the Connecticut Steins. Valley, you got 2 Goldens. These are 2. The puppies are not quite a year. They'll turn a year in December. And then Milo is 13. He's the elder statesman. He likes Bruno, especially likes wrestling with Milo. Got a couple more minutes. How common is it to set up dual EFI systems? So you can switch fuel on the fly? That's not uncommon. People do that. They have sometimes guys will have second fuel tanks and pumps and stuff that they'll add good fuel to nitrous setups sometimes. And then you can, what they do is run flex fuel sensors so that the EFI will adjust based on what the fuel is. My German Shepherd turns 1 in December. German Shepherd puppies are awesome. Spend money on the fuel system. Yeah, that's a good idea. You should, if you're putting a turbo on an LS, you should go oversize on your fuel system because you're not going to stay at 700 horsepower. You're going to, if everything works and it runs perfect and you have a GT45 on a 6-liter, you're going to go to an S475. I found out my 95 Ford van is actually a 96. So I have an OBD2 300. So you got the Fuelie 300 then. Got my torque cam for my 4.8 liter. Mine are 5 and 6 track dogs. Cool. Flex fuel sensor. That's right. Five and 6 years old. That's a good age. They're still in really good shape and stuff, and they run around and still do crazy stuff. Milo used to run with me a lot. He did an 8-mile run with me one time. That's the farthest that I've taken him, but he was good. Now he trots more, but he does go to the top of our trail hills and stuff and climbs up. We go up Wyckoff Hill and stuff. He goes up all of them. He's a little slower than he used to be, like all of us, but he's still good. So, Dean, that one has an EEC4 on it. I don't know about the 6-cylinder stuff. My Pitbull is a 90-pound baby. That's cool. Yeah, your dog is a reflection of how well you treat it. Misfire indicator on the crank pulley. Still TFI. So does it have a sensor like a crank sensor like the Explorer has on it, Dean? 64%. If I get a different damper from the guys at ATI, I'll also get an 8-rib. We're not getting any belt slippage, but you want to just make sure that you don't have any belt slippage. 11 kisses for everything and everyone. That's how these dogs are. They just want to go see everybody. EEC 5, okay. Yeah, 96, that would make more sense. Come on, Dean. You don't know your EECs? %. So we're going to end our poll there. 64, 30, 36. You 36%ers are going to be sorry. I don't know if you will or not. What's easier, a factory harness or ECU and ECU or HOLLEY? For me, the HOLLEY is, because I've done it like 8 bajillion times. But I don't know about hooking it up to all the rest of the stuff. If the factory harness is already there and you have the harness already in place and then you have the ECU, then that would be easy too. The M90 and 3800 stuff is fun to watch. Yeah, we're getting the M90 ready for some serious power. For some turbo power. Poor man blames a spell check. What is the capital of Czechoslovakia? It's not Warsaw. No. Prague. Okay. It's the only really big city that I would know in Czechoslovakia, so I probably should have guessed that, but that's where Blade was. Thanks for the 3800 test. Yeah, I'm looking forward to run the 3800. It's going to make big power. It's already made pretty good power. It's already made 6 plus. How do you do an LS1 to M90 intake adapter? Can someone answer me, please? Yes, I did that. I made the adapter plate. And it works on an LS1. It works on an LS2. It works on an LS3. Only because the adapter plate bolts to a HOLLEY high RAM or a HOLLEY low RAM. So you also have to have that intake manifold. Stock LQ4 crank limit. So far, we've done 1500 plus horsepower with that. So it's way beyond where you're going. I know. Put an LM7 into a 95 YJ factory harness and PCM. Send the PCM to take out the theft system, and then the harness made a power distribution block. Whole thing cost about $110 between both. Ran on 4 fuses and two relays. That's good then. That's cheap. The cylinder distribution was surprising. The blower's right over those holes. I know it's directly over those holes. I thought for sure we we're going to see at least some, like half an airfield point or a full airfield point or something. Dean, the dancing machine. Chucky baby. Da, 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 da. Who knew that Chuck Barris was an international spy? Got 3 minutes. Now my ad's got to run. Yep, now you have the song. That's right. You're going to be singing Gene, the dancing machine all day long. I should see if that's a free song that I could put on there. I know, Burns. I know. I should have known Brock. I should have thought Blade. Sensor is one thing, and the fuel pump is another. Dancing Dean. Richard, I got the vibrant vacuum manifold from Amazon, $36. Dude, I just got $10 today. I could totally afford that now. A question, is there anywhere I can check my CFM near Southern California? What is it you're wanting to check? Are you wanting to check the airflow of your cylinder heads? What is it you're wanting to flow test? And then we can probably direct you to where that can be done. I'm looking forward to getting back down to West Tech. I want to build the twin M90. Might be paying more than ABBA paid taxes. Hey, don't disrespect ABBA. I know. I thought that, speaking of Blade, that Blade 2 is better than Blade 1. I have 3 cylinder heads that same motor, but 3 different generations. So you have what heads are they from? What motor are they from? Oh, from a VQ engine. I don't know anybody who's set up to run the Nissan, because a lot of times you have to make custom plates with angled screws welded to them, or drilled and threaded things so that you can put your adjuster so that you can push the valve springs down to the right lift so that you can airflow test them. So that might be something that you can do so that they're ready to test. If you have all that, then just airflow testing is not a big deal. The Trophy 4-cylinder is ready to run. It's already steady. Dun, 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 dun. See, it's all going to happen. I'm going to be doing that dance tonight for Lisa. Do you know if offhand there's a minimum flow rate required for the E85 sensor? I think it just has to be in constant contact with it. Just to take a good sample. And on that note, it is time to go. Motorhead, you've been a fan since Mustangs Fast Forward. That's way back in the day. That is post-turbo, though. Czech Republic. And on that note, it is time to go, but I will be back tonight at 7 p.m. Pacific Standard Time-ish. Sometimes we try to come on early because I can't wait to just see everybody. Talk to my boys, yo. But I will be back tonight. If you have not, please go take a look at the video I put on airfield distribution. There's no way that it doesn't favor those front 4 cylinders, and yet that's why we test. I'll see you guys all tonight.